Hello, in this video we are discussing inverse district Fourier transform IDFT and we are solving one example based on it. Now example is find IDFT inverse district Fourier transform of x of k is equal to 10 minus 2 plus 2j minus 2 minus 2 minus 2j. So the DFT is given to us. This is x of k means DFT frequency domain. And we have to find inverse DFT means time domain x of n. Now we know how to find the DFT. DFT equation, we already know it. X of k is equal to n varies from 0 to n minus 1 x of n w n k n. This is twiddle factor matrix and this is the x of k DFT. Now in matrix form we already know how to find the DFT, how to write the twiddle factor matrix. This is x of k which is given to us and this is x of n time domain sequence and this is our twiddle factor matrix and we know how to find the values of this w40, w41, w42 using row and column indexing and we know this is our twiddle factor matrix to find the DFT. But now we are interested in inverse DFT. That means x of k is given to us and we want to find x of n. And the definition of inverse DFT is x of n is equal to 1 by n. K varies from 0 to n minus 1. X of k wn minus kn where n varies from 0 to n minus 1. If you check the definition of DFT and inverse DFT, you can see what is the change. Here capital X of k and here small x of n. That is frequency domain, time domain. Then 1 by n is here in inverse DFT. Then see the limits. N varies from 0 to n minus 1. Here k varies from 0 to n minus 1. Here x of n and x of k. So you can check here this capital X replaced by small x, k replaced by n and here small x replaced by capital X, n replaced by k. Now twiddle factor matrix wn kn, here wn minus kn means these are complex conjugate of each other. That means to find inverse DFT, the twiddle factor matrix is complex conjugate of the matrix which we are using to find the DFT. Now, if I want to remember only one twiddle factor matrix which we are using to find the DFT, we need to change the other terms. See, now I will take conjugate of this inverse DFT equation, x star of n, conjugate of this x of n, 1 by n as it is, k varies from 0 to n minus 1 summation. Conjugate of this one is x star of k and conjugate of this twiddle factor wn minus kn, its conjugate is wn kn. Now you can check the definition of inverse DFT complex conjugate and your DFT. You can check this capital X of k replaced with the small x star and this k replaced with the n. 1 by n summation k varies from 0 to n minus 1. This small x of n, here it is capital X of k, x star of k. And you can check twiddle factor matrix is same, WNKN, WNKN. So in inverse DFT, to find the inverse DFT, what I will do? I will refer same twiddle factor matrix and I will get x star of n instead of x of n. So I will first calculate x star of n and to get the x of n, I will take the conjugate of this one. So what you need to find that x star of n? You need x star of k. That means the input should be instead of x of k, our input is conjugate of x of k and twiddle factor matrix is same which we are using in a DFT equation. So there are two methods to find the inverse DFT. Either we can calculate x star of n and then we convert it into x of n, In that case, advantage is we can refer the same Tudel factor matrix which we are using to find the DFT. Another, if we want to refer original inverse DFT equation instead of taking complex conjugate, what you have to do? X of n 1 by n, here x of k, and here the complex conjugate of Tudel factor matrix you have to use. But I prefer the second option, that is complex conjugate. Instead of using complex conjugate of Tudel factor matrix, I will refer same Tudel factor matrix of your DFT equation, and I will input instead of x of k, x star of k, and I will calculate x star of n, and then to get x of n, I will take its complex conjugate. Let's solve this equation. So here we are referring same Tudel factor matrix in both DFT and inverse DFT. So according to our method, x star of n is the point which we want to find, then same Tudel factor matrix, then 1 by n, and this is x star of k. Now x of k, we know what is our x of k. X of k is this one, 10 minus 2 plus 2j minus 2 minus 2 minus 2j. Now here you need to take care, instead of input direct x of k, we have to take its conjugate, and we have to input x star of k. So its conjugate is x star of k is 10 real value as it is, then minus 2 minus 2j, its complex conjugate, then minus 2 as it is real value. Now this complex value minus 2 minus 2j, complex conjugate is minus 2 plus 2j. So where there is a plus j, you have to replace by minus j, minus j you have to replace by plus j in case of complex conjugate. So here my input will be complex conjugate of x of k is x star of k. So here this complex conjugate is my input. And here I will prefer same Tudel factor matrix which we are using to find the DFT. So to find these values W40, W41, W42, you can use this phasor diagram. We already know this, so I will directly use the matrix here. Now do matrix multiplication. First row of this one get multiply with this first column. Then second row of this one will get multiply with this first column. Like this, first row will get 1 into 10, 1 into minus 2 minus 2j, then 1 into minus 2 and 1 into minus 2 plus 2j. Similarly, 1 into 10, second row, plus minus j minus 2j into minus 2 minus 2j. So minus j multiply with minus 2 is plus 2j, then minus j multiply with minus 2j is plus 2j square. J square is minus 1. So it becomes plus 2j square means minus 2. J square is minus 1. So it becomes minus 2. Like this, minus 1 multiply with minus 2 plus 2. Then j multiply with minus 2 plus 2j square. So minus 2 into j is minus 2j, and 2j into j is 2j square. So plus 2j square is minus 1. That's why it is minus 2. Like this, third row get multiply with this column. Last row will get multiply with this column, and we will get this matrix multiplication. Now here you can check first row, this minus 2j plus 2j. We can cancel it. Then second row, this minus 2j plus 2j and minus 2 plus 2. Third row, plus 2 minus 2 plus 2j minus 2j. So we can cancel this. Then last row, minus 2j plus 2j. Now we'll see what is our result. So 10 minus minus 2 minus 2 minus 2. So 10 minus 6, 4. 10 minus 2, 8. Then 10 plus 2, 12. 10 plus 16, and this will all these will get divided by 1 by divided by 4 means it becomes 4 by 4 1, 8 by 4 2, 12 by 4 is 3, 16 by 4 is 4. So this is 1, 2, 3, 4. But remember, this is x star of n, complex conjugate of x star of n. We are interested in x of n. So we have to take the conjugate of the answer which we are getting. But here all the values of real, so its conjugate remains same. So our x of n is 1, 2, 3, 4. But in case if these answers are in a complex conjugate form, remember this thing, this whatever you are getting is nothing but x star of n, not x of n. So to get x of n, you have to take complex conjugate of this one. Here it remains same because all the values are real. So this is the way how we can find inverse DFT. First thing, to find the inverse DFT, we are preparing same Tudel factor matrix which we are using for DFT. So DFT and inverse DFT Tudel factor matrix, if we want to use the same Tudel factor matrix, what we have to do? Here, instead of x of n, we are writing x star of n, and instead of x of k, we are writing x star of k. Otherwise, what is other option? If you are writing x of n only and here x of k only, you have to use the complex conjugate of this matrix. But what we are doing? We are using same Tudel factor matrix and we are taking complex conjugate of x of n, that is x star of n, and complex conjugate of x of k, that is x star of k. So whenever you are solving using this method, remember this thing, the input given to you is x of k. So when you are writing here, you have to take x star of k and then do the matrix multiplication. Then you will get x star of n, and to get x of n, you have to take its complex conjugate. So this is the way we are finding inverse DFT. Thank you.